Hello, and today we're going to look at consequences of climate change, the North Atlantic Conveyor, the Gulf Stream, as it's otherwise known. We're talking about ocean currents. And ocean currents are really important. So ocean currents are ways in which heat is distributed. Heat is distributed by water. And water is a really good distributor of heat because it has a high specific heat capacity. And this can have a big influence on land. So things like precipitation and temperature are heavily influenced by the ocean, especially coastal regions. They are big global spanning systems and are very complex, and they are typically driven by processes that occur in the atmosphere. So that's why we're learning about it now. So, for example, some of the causes of ocean currents include things like friction caused by wind. So when the wind blows along the surface, so this is our wind blowing in this direction, it sort of piles up the water and causes it to move along with it. Okay, so this wind causes the ocean to move and can cause big ocean spanning currents. You have evaporation. So this causes water to flow in to replace water that has been lost. So if we have our water here, we have slightly warmer water over here for whatever reason. Water will evaporate, and instead of just this area of the ocean sort of going down a little bit, what happens is cold water is brought in from other parts of the ocean to replace it. It's drawn in. So replacement. The other thing that causes evaporation can cause is changes in density. So we might have changes in density because as water evaporates, it leaves behind the salt and other dissolved ionic compounds in the water, which increases its density. So loss of water. This results in increased concentration of salt. This means an increased density. So this increased density means that the water is more likely to sink. As dense water is more likely to sink, it needs to be replaced by something else. So it will draw in water to replace it. So evaporation can cause water to be drawn in through replacement directly or changes in density, which draws in water. And the last thing that can happen as well is things like changes in temperature. So these temperature changes, so we have hot water, it's heated up, this will have a lower density. So it's more likely to rise up, whereas cold water has a high density, and this causes it to sink down. And together, these changes in salinity and temperature cause something called a thermohaline circulation. So this is the movement of water due to thermo being temperature and haline being salinity, which means the amount of salt. So changes in density due to its temperature and salinity. And this happens at a global scale. Now, one of these thermohaline circulations that you need to know about is the North Atlantic Conveyor. And this is just part of this global thermohaline circulation, and it takes place in the North Atlantic. What happens is warm water from equatorial regions flows along in this sort of area here, up through the Bahamas, and sort of moves northwards around the coast of America, and then across the coast of the United Kingdom, crossing the Atlantic. Now, as this water travels northwards, it will actually start to cool down and lose some of its heat. And this heat that it is losing is one of the reasons why the UK is relatively warm, especially when you compare it to other regions at the same latitude. So places like areas in Canada at similar sort of latitudes, or Moscow, for example, which is over here somewhere. These are both very cold in the winter compared to the UK, which is more mild in comparison. So this hot water is what's this Gulf Stream, this North Atlantic Conveyor is what's doing that. As it comes up though, it cools down, and as it cools, it will become more dense and will start to sink. And it will it will drop down into the depths of the ocean. And the other thing that's happening as it comes along is evaporation. So this hot water evaporates, making it more saline. Okay, so the other thing that is driving it along is prevailing winds like this, which should provide us with friction to move it along. Once it sinks, it drops down into the deep waters and returns southwards very deep down in the water. Okay, so our North Atlantic Conveyor is driven by prevailing winds, which move it from southwest to northeast. And as the water cools and evaporates, becomes more dense. And this means that it sinks, and water is drawn in to replace it. Now, what we can do is sort of draw that in a different way. So at the moment, we're looking sort of top down. If we draw it looking side on, what we have then is the surface of the ocean. We have our prevailing winds. So this is near the equator. This is North Atlantic near Greenland. So let's draw Greenland here with its ice caps on. So this drags the water along. We have warm water from the equator traveling along. As it travels, it starts to cool and sinks. So it cools, becomes dense, sinks, and that will there draw in more water. And there's that returning water and current along the sea floor. Okay, so cold water returns at depth. You also have this evaporation taking place, which makes it leaves behind some of the salt, making the water more dense as well. So sort of increase the salt concentration slightly.